Hello and welcome back, but this time not for the content or the material, but instead for review. Now, we're preparing for that AP exam, right? And no matter the changes or how different or even how normal it is, it's still important that you know the content. So although I am going to give a focus on the skills that College Board lays out, you do want to make sure that you first know the content. And that's what these slides are really meant for. So let's go ahead and get started. So of course, we're going to start with Unit 1, Scientific Foundations. But what I want to do is point out to you what I'm going to call unit understanding. So rather than giving you a big slide of all the learning targets as laid out by College Board, which are super important, I'm going to try and give them to you in almost like themes or categories so that you're able to digest those a little bit better. I'm also showing you the skills on this slide. These skills, skill 1, 2, and 3, are as follows from College Board. Skill 1 is concept understanding. So in Unit 1, Intro to Psychology and Ethical Guidelines is what you're going to need to know as far as concept understanding. Skill 2 is data analysis. So in Unit 1, that's all the statistical analysis and being able to analyze data. And then skill 3 is scientific investigation, where we analyze psychological research studies. And so skill 3 in Unit 1 would be research methods and experiments. Those are kind of the topics that apply to those specific skills. Please know that these slides and these videos I'm making are not entirely comprehensive. That yes, they are comprehensive in that they cover a lot, but they by far do not cover everything, because I'm hoping that these are quick review videos that accompany these study guides that you hopefully already have as well. If not, you can check out the link below where you're watching. But you really should be doing studying beyond this video, particularly vocabulary studying. So have those lists, get on Quizlet, whatever that looks like, and how you study your vocab and get it done. So history is kind of what I mean when you see Intro to Psychology in that topics list there, and that you just have to have conceptual understanding here. And I'm going to do this really briefly. The big understandings that you need to have is that psychology started from philosophy and then eventually became a science of psychology. The old schools of thought kind of started with functionalism and structuralism first, and you'll want to study those as kind of like you would a vocabulary term. But the old schools of thought really that kind of branched from functionalism and structuralism that we still see some remnants and breadcrumbs of now is behaviorism and psychoanalysis. So just kind of understanding that history and how psychology became a science is an important understanding here. All right, the really big one as far as the introduction to psychology is the perspectives or the approaches. And you have in the study guide where you're watching a chart just like this one. And I'm going to go through these quickly, so I encourage you to pause and jot these down. Biological or neuroscience is very physically, anatomically focused, right? It wants to know what is going on in the anatomy of the brain or the nervous system and how that impacts behavior. So that's kind of like the overview, right? Having the buzzwords is really helpful though. So those are the type of words that you'll see in the question that might indicate to you, oh, this is the perspective or the approach that they are talking about. Really anything with the anatomy, so maybe like a brain lesion, a lobotomy, anything that talks about the physical, like a reduction in serotonin and how that impacts behavior, right? All of those being how the body or brain impacts behavior. Evolutionary is all about natural selection of behavior and what that looks like over time, and that we are primarily motivated to spread our gene pool, and therefore that is our motivation in all of our behavior. So buzzwords being natural selection, gene pool, reproduction, that kind of thing. Behavior genetics takes our behavior and how it's impacted, of course, by our genetics, but also our environment. So how our genes predispose us, and then how our environment draws out those genes. Psychoanalytic puts an emphasis on the unconscious mind, and that really is the buzzword there, in that it directs all behavior. So free association being another buzzword there, how traumas lead to repression into the unconscious. Again, this is broad bird's eye view review. So make sure you're studying this stuff. Behavioral being the learning process. So learning being a big buzzword. Anything with reinforcement, the increase or decrease of behavior. Cognitive is when you think, cognitive, thinking. It's all about thinking, thought processes, processing, reasoning, a lot of times memory and how that's impacted as well. Humanists emphasize anything about human growth and potential, and any self-word, self-actualization, concept, esteem, worth, all of that is humanistic. And then social cultural is not just your family, because your family could very much give you a genetic predisposition, right? Social cultural, yes, is family, but it's everybody outside of your family too. So neighborhood, your demographic, socioeconomic levels, and then the big picture being culture and social impact as well. Ethics is important, and what I list on the screen here for you is what's important about it. And so it's important for you to conceptually understand how this stuff might apply in a scenario on an FRQ question. So understanding who the APA is and how they set the guidelines. And then the IRB is the institution who approves all research having to have informed consent from their participants. They have to limit deception. In fact, deception should only be necessary to the nature of the experiment or research, and that it wouldn't be successful without it. Protection from harm and discomfort, pretty self-explanatory. Confidentiality, the participants know that their information is going to be released. And then debriefing, and that the participant must leave the research in the same state that they arrived. Okay, so a lot of times we think about that with harm and discomfort, but it could be any kind of emotional state. It could even be like intoxication, right? That kind of altered state of consciousness as well. Research methods is super important, and this is where we're going to start to talk about skill 3. Remember, skill 3 being that scientific investigation, being able to really analyze the research studies. And you have to have an understanding of research methods to do that. So we're going to look at all of these things, a few of them more deeply, but I'm going to give a brief overview here really quick. We're going to talk more about correlational studies and its data and how the correlation coefficient and scatter plot show those relationships. But how you obtain correlational data is through things like naturalistic observation, where the researcher does not interfere at all with the people who they are observing. But that also leads to the Hawthorne effect. You want to look that one up and study it as well. Case study is another one. The problem, though, with a case study where you're meeting with an individual or a small group of people is that you're unable to generalize to the population. So you have to be careful with that. And then a survey is oftentimes seen as the most effective form of, accumulating data for research, but it doesn't always give the whole picture. Now, a quasi-experiment is important as well in that there are ethical guidelines that researchers have to meet, right? But that doesn't mean that, so let's say that, a researcher wants to see the effects of psychoactive drugs on people, or the effects of caffeine or nicotine or anything like that on a developing baby, a fetus, right? The researcher cannot assign ethically to the experimental control group who should or shouldn't get pregnant. That's not good. And then who should or shouldn't consume artificial sweeteners or nicotine or caffeine, and likewise with psychoactive drugs. They can't say to their experimental group, you guys go do cocaine. That's just not ethical. But there are people in the world who do those things, and so they find them and do a quasi-experiment. Operational definitions are huge. And so I want you to take some space to really write those down here as I chat about them. Operational definitions exist so that researchers can replicate the experiment or the research, and that it remain the same research, right? That they are measuring the same variables. So you need to operationally define your independent and dependent variables, specifically the dependent variable. It has to be measurable. So in an operational definition, you have to state how you are going to measure intelligence, how you're going to measure happiness, how you're going to measure their attitudes, how you're going to measure their performance. Anything that you are measuring, you have to state what the test is, essentially, how you are measuring or assessing that. And that's all so that the research can be replicated. All right, so correlations, there's positive and negative. So I always tell my students to have their fingers out like this, and that a positive correlation is when variables increase and decrease together. So the more you drive, the more gas you use. Negative would be opposite, right? So two variables move in opposite directions, whether up or down. So miles traveled is the less gas you have, right? Or the more gas you have, the less you have traveled. They go in the opposite directions. Now, it's really important to know how those are depicted on a scatter plot, and that the positive and negative thing, that name comes about because of the slope, the direction of the slope. And is it positive or is it negative? Hence telling us the direction of the correlation, or no correlation at all. So the strength of the correlation on a graph is indicated by the line of best fit and how close knit the dots on the scatter plots might be. Now the correlation coefficient I'll talk about really quickly. You can see the +1 or -1 here. It's important for you to look at one item at a time, the plus or negative sign and then the number, okay? And that those are two separate things. Plus or minus simply shows the direction. The number alone, not the negative or positive, shows the strength. So the closer to 1, whether it's negative or positive, does not matter. The closer to 1, the stronger it is. In fact, 1 being a perfect correlation. And then the closer to 0, the weaker it is. All right, so the next important part of scientific foundations is experiments. And you really want to start your understanding here in recognizing what is the population and how in any research method, particularly experiments, we sample from that. And that we randomly sample from that in hopes of obtaining a representative sample, and that the sample is representative of the population. Now, again, I'm going through these quickly because you should know these things. It's just a review. If you don't, pause, go study those terms and really learn them, and then come back. Now, just because a sample is random doesn't make it representative, and a lot of times people will use a stratified sample. So if your population is all students at a high school, you stratify it by drawing randomly from a list of freshmen, a list of sophomores, a list of juniors, a list of seniors. That would be a stratified sample. Then once you have your sample, you will randomly assign it. Okay, so making sure that you know the difference between random sample and random assignment. We randomly sample so that our sample is representative of our population. We randomly assign our participants into experimental or control group so that we control for any pre-existing differences. So that if we're studying caffeine, we don't put all the caffeine addicts who've built up tolerance into the experimental group and therefore confounds our research. So the experimental group gets the, quote, special treatment, that degree of the independent variable, where the control group would get the non-special treatment of the independent variable and is the group that we control our results to. They could also get the placebo, right? The independent variable being what's assigned to the experimental or control group, and the dependent variable being what we are measuring. Confounding variables are any variables that may exist that we don't want to exist that confound our research. So the example I stated earlier, if we're studying the effects of caffeine and we put all the caffeine addicts into one of our groups, either of them, but they're all in one, that's going to skew our results and therefore confound our research. The placebo being the non-special treatment, but it's a placebo because they don't know if they're getting it or not, and in fact think that they are. Now, the last topic is statistics, and this one is where you're looking at the skills, is skill 2, right? So this is skill 2, which is analyze and interpret quantitative data. There is going to be an entire FRQ over this and skill 3, the scientific investigation. So knowing the difference between descriptive and inferential statistics. Descriptive stats simply describe the data. So measures of central tendency, mean, median, and mode, and variation with range and standard deviation. So standard deviation being the average distance from the mean, okay, on a distribution of scores, which is hopefully normal. And then making sure that you understand also skewed distribution and data, which I'm going to show you more in just a little bit, as well as those graphic representations of data. Inferential statistics being the null hypothesis and statistical significance. Let's talk really quickly about the graphic representations of data. Okay, so I find most of this stuff easier to describe if I'm able to draw it. So I'm just on a piece of computer paper here showing you what I got. So a normal distribution is a distribution of scores that's on that bell-like curve, right? Hopefully, again, this is not new information. It's just review for you. So the curve shows where the scores fall. And then each one of these lines is just one deviation away from the mean. Okay, so this line here in the center being the mean, median, and mode line. So it is 0 standard deviations away from the mean. Now, something that I want to point your attention to is a graph that I have not talked a lot about, but is one that's important for this test, and that is a histogram. And here's the thing, a histogram is essentially the same thing as this kind of distribution of scores. It's just done in what looks like a bar graph. Okay, so if you notice, like this is 1, 2, 3 standard deviations, or -1, -2, -3 standard deviations. But a histogram is essentially the same thing. So what we have is it shows the data continuously. The bars do touch each other. But if you notice, they essentially look just like, if they are normally distributed, they look just like the normal curve. And so each one of these lines indicates a range. Okay, so let's say that this is a histogram or a normal distribution of like test scores on an AP test, right? And like 100, like 0% down here and 100% up here. The mean was like, I don't know, 70%, right? And so the students that score, I'm gonna use a different color, from here to here, let's say that our standard deviation equals 5, right? So the students, the range that they score in this area is 70 to 75. So the students that fall in this area here all scored between a 70 and 75. That's what makes it a histogram, is that it's a range, right? Whereas in a bar graph, each one of the bars is separate from each other because it is a separate piece of data. So this would show that, like, let's say that you have 10th, 11th, and 12th graders all in your AP class, right? And so like this is 100% on the test, 0%, something like that. This is the 10th grader scores, this is the 11th grader scores, this is the 12th graders scores. They are separate from each other because it's not continuous data. This, on a histogram or a normal distribution, is continuous data. So like down here, if the standard deviation is 5, it would be jumped down to 65%. And the percentages that you need to memorize on a normal distribution, on a normal curve, would be the same here if it is normally distributed. If it is normally distributed. Now, a frequency distribution could be something that you're asked about too, and that is simply just a T-chart, right? So you would have your test scores over here, right? Which would be everything from 0 to 100 points, let's say, if it's, percentages. And then over here would be the frequency. So the number of times that each one of the scores was scored. So 75, 70, and 65 would be where most of your scores are. So if you like tallied those up, right? Most of your scores would fall there, whereas fewer tallies would be even down here, right? And then you would just say like, oh, let's say 30 students scored there, whereas only like 4 scored, you know, in the very low ranges, or like 2 or 4 in like the high ranges. But even still, if you turn that on its side, it very much looks like a bell curve. It could be skewed. The frequency distribution, if you tally it and turn it sideways, will look like a distribution. But a frequency distribution by itself, without turning it on its side, would just be those numbers. Now, skewed data is what we want to talk about, right? A normal distribution has this pretty bell curve, but skewed data, or skewed curves, let's say, right? They're skewed in that they have what's called outliers in their data. And you need to know the difference between a positive skew and a negative skew. And what I tell my students is that the positive or negative skew is all about where the skew or the outlier is on the graph. Okay, so a positive skew means an outlier will be on what I say is the positive side. It's not actually positive because negative would be over here, but it's on like the higher end, meaning most students score down here, let's say in the 30% range, and you had a few students score in the 90 to 100. So it'll be high here and then low over here. Whereas negative, most students, the outlier, ask yourself where is the outlier, will be on the low or closer to the negative end. So it'll be high up top and then lower down there. A fun way to do this is to ask where's the tail of the whale, right? Where's the tail of the whale? Is it closer to negative? Therefore, it's a negative skew. If it's higher and further away from negative, then it is a positive skew. All right, so let's talk about statistical significance to wrap this up really quickly, and then with null hypothesis. So significance of your data is determined statistically. That's all it means. And that if your data is significant, it means that you're onto something. It means that your independent variable actually cause the difference in your dependent variable between your two groups, okay? And they have statistics, lots of formulas that you need to know nothing about in order to know that it is significant, okay? So if your data is statistically significant, it means that the difference in your groups, in the measures of your dependent variable, were not due to chance. And so p-value is what indicates that. It should be no greater than 0.05 or 5%, meaning that no more than 5% chance, or no more than 5% of your data is due to chance, meaning the other 95% is in fact due to your independent variable. And then lastly, we have the null hypothesis, which just says that it's important for us to consider what the opposite might be, meaning if we're wrong. I don't know about you, that makes a lot of sense, is to make sure that, I need to consider if I'm wrong, because if I am, I should probably be prepared for that. And so there's types of errors that happen if the null is true or false, and if we reject or accept the null. So in that first box there, it's a type 1 error. And so I use this scenario about removing an appendix and if it's appendicitis or not. And you can see that if we do a type 1 error, we perform unnecessary surgery. Whereas here it would be the correct decision, meaning we avoided unnecessary surgery and investigate other potential causes. If the null's false and we reject the null, we made the correct decision. The appendix are removed, patient fully recovers. In this one, we make a type 2 error, do not remove the appendix, it explodes and risks the patient's death. Okay, so this is why it's important for us to really consider a null. Now, this was super fast, but it's meant to be. So this is a really important video though too, because it really sets us up to be able to analyze data for the rest of the course. So I hope that you found this helpful, and stay tuned for the next video. Bye for now.